In this unit, we are going to learn about color theory. What do you know about color? Do you know why we see color? As the full spectrum of visible light travels through a prism, the wavelengths separate into the colors of the rainbow. Each color is a different wavelength. The human eye and brain together translate light into color. Light receptors within the eye transmit the message to the brain, and a familiar sensation is produced, which makes us feel a certain color. Probably the hardest concept to fully grasp about color is that color is all in your head. Literally, it's a sensation just like touch. In other words, grass is not green and the sky is not blue. Rather, they have physical properties that make you perceive green and blue. Light reaches your eye, it stimulates the sensors in your eye. Those sensors register the photons, and they report the sensation to your brain. Notice how different the color of the trees are in these two photographs. Why is this? Well, the color you see for an object depends on the mix of light frequencies that reach your eye. That mix depends on two things: the frequency the object absorbs and the frequency in the original light source. Objects actually have a different color under daylight than under incandescent light and fluorescent light. In fact, things will have different colors in daylight at different times of the day. As we learn to adjust color in a drawing, we need to remember that color changes based on light source, time of day, and environment. In this unit, we will learn how to adjust color using the concepts in color theory. So now that we understand why we see color, where do colors come from? The inner surfaces of your eyes contain photoreceptors, specialized cells that are sensitive to light and relay messages to your brain. You're able to see an object when light from the object enters your eyes and strikes these photoreceptors. A pigment is a material that, as the result of wavelength absorption, reflects a certain color. Pigments may be organic, meaning found in nature, or synthetic, which means they were created in a lab. For example, white paint was originally derived from sedimentary minerals. In this unit, we will explore color with the use of colored pencils. While every artist knows that colored pencils come in a wide range of colors, not every artist knows how that range is created.
Colored pencils start with a combination of pigments. Every shade has a specific pigment recipe. They produce a large quantity of one shade at a time. Following that color's recipe, they meticulously weigh the different portions of ingredients.
So now that we understand why we see color and where colors come from, how do we start to use this knowledge in our drawings? Remember, color changes. Notice the difference in the color of the red on the left of the cherries as compared to the color of the red on the right of the cherries. As the artist, we need to observe these changes and adjust the color accordingly. Returning to the image, look at how different the blue looks on the left side of the box as compared to the right side of the box. We can create these color changes by referencing the color wheel to create new hues, tints, tones, and shades. When working with color, you should keep a color wheel by your side. The purpose of the color wheel is to show the relationships between the colors that are found in the visible light spectrum. Let's review some color vocabulary that you probably covered in your foundation art course. The color wheel is created using the primary colors: red, blue, and yellow. Secondary colors are created by mixing two primary colors. These are green, violet, and orange. A new term may be tertiary colors or intermediate. These are created by mixing a primary with a secondary. So for instance, blue-green, red-violet, and yellow-orange. Now that we've reviewed the basic 12 colors that make up the color wheel, let's talk about their relationships to one another. You are probably familiar with the term complementary colors. These are colors that are located across from one another on the color wheel. Another term you've probably heard is analogous colors. Analogous colors are located next to one another on the color wheel and share similar properties. Now that we've reviewed the basics of the color wheel and basic color relationships, let's look a little closer at the qualities of color. The hue is the overall appearance of color that you see. Is it red, blue, yellow, green? Color intensity, also called saturation, refers to the brightness of a color. A color is at its full intensity when not mixed with black or white. It's called a pure hue. You can change the intensity of a color by making it duller or more neutral. In this lesson, we will focus on how to change a color's intensity by creating tints, tones, and shades. Most artists know that a tint is created by adding white, resulting in a lighter value, and that a shade is created by adding black, creating a darker value. But what about those in-between values? I'm going to share two strategies for adjusting a color's intensity to create those in-between values, also known as tones. You can create different tones of color by 1. Adding grays, or 2. By adding its complement. This is the color found directly opposite on the traditional color wheel. Here is a simple example of how to create a range of values using hue, in this case blue, plus white, gray, and black. Here is a more sophisticated example of how tints, tones, and shades work. As you move up the scale towards white, the color gets lighter. As you move down the scale towards black, the color gets darker. Notice as you move towards the center of the scale, which is also moving towards the complement on the other side, the color gets duller. In contrast, as you move away from the center of the scale, the hue gets. To summarize, color theory is both the science and art of using color. It explains how humans perceive color and the visual effects of how colors mix. Color theory will help you build your artistic skill, and that will help you get artworks that you love. Let's start with some exercises to see how all this works.